As you might be aware, Ganesh, the whole data center market size right now was probably like close to value around $301 billion in 2023 USD. And it's expected to advance at, the last I checked, a compound annual growth rate of about 10.1% between 2024 to 2030. And that potentially will get us to about 622 billion or something by 2030. Crazy, like absolutely astounding. And however, we typically tend to think of power, geographical locations, maximizing capacity within a facility when it comes to data centers. In your opinion, how does water become a crucial topic to be discussed here?
Yeah. So yeah, thanks for that, Meena. I think before diving into water specifically, it's useful to zoom out a little and assess the lay of the land, as it were. And so AI is everywhere. It's on everyone's mind. Everyone has an AI strategy. Every business has an AI strategy. So they're either trying to benefit from AI or survive the effects of AI. And so there's a lot of hype when it comes to AI. So the first step, I think, is really to try and evaluate if all of this hype is even justified, right? So when you run the numbers, you look at CapEx plans from big players like Google, Microsoft, and the others. It appears that the part of AI that is real, that we should pay attention to now and into the future, is the infrastructure build that is accompanying this boom in demand for AI applications. So CapEx on AI infrastructure that you mentioned, which is really the construction of AI specific data centers, it's expected to grow at 10 to 15 at minimum and 25 to 30% realistically all the way to 2032, right? And so the conclusion from that is that this is decidedly not hype, right? So this is billions and billions of dollars of real money being deployed into the creation of new AI capacity, right? So once we've convinced ourselves that the capex on AI is real and it's growing really rapidly, you can then begin to disentangle what it means further downstream, right? And so you can think in terms of what is needed to service demand for AI applications. So you need AI data centers, right? So AI data centers are basically data centers with specialized equipment for serving only AI workloads, right? So they're centered around GPUs, for instance. So in addition to that, to power these data centers, you need enormous amounts of electricity, right? So those are the two things that typically come up when you talk about AI growth. So you talk about power and you talk about power capacity to really operate these data centers, and you talk about equipment, and that's the reason why you see NVIDIA stock blowing up and so on, right? So the thing that gets less attention comparatively is that GPUs need to be cooled, and the amount of power that GPUs use up is very high as compared to conventional compute workloads, right? And so the cooling aspect of things sort of generally does not get talked about as much as power and compute, right? And that's really where water enters into the picture. And we'll get into this in a little more detail, but structurally speaking, GPUs and GPU data centers, GPU-centered computing in general requires a lot more cooling than conventional compute. And you typically need to focus on solutions that have not been used in the past. You need liquid-based cooling solutions rather than HVAC-based cooling solutions. And that's really where water enters into the picture. And that's really what we wanted to get into when we created this report on water quality preparedness in the age of AI. So I encourage everyone who's listening to this conversation to go and download this report and look into it, because there's a lot more detail in it than we're talking about here. But that's really where water enters into the conversation.
But as you think about this exponential growth of data, Ganesh, how is AI's push with this need and demand changing infrastructure as we know it for data centers? I mean, what are people not talking about? What are things that we are just not even assessing as top of mind for us today.
Right. So I think, like we discussed, in the previous question, the first thing that one needs to know about AI-focused data centers from an infrastructure perspective is that they're centered around the GPU as the backbone computing device, not a CPU. And when you think about it, the reason for that is all of these large language models that are that are very hot right now. You can abstract the details out, and you can think about them as a series of matrix multiplications, right? And GPUs do that several orders of magnitude more efficiently than CPUs, right? So that choice of the GPU as the compute backbone, that has all sorts of downstream impacts, right? So GPU server racks, for instance, they're far more dense than CPU server racks, and so they consume a lot more power. So if a CPU server rack consumes 10 kilowatt hours of power, GPU server racks consume typically between twice to 5 times of that, right? So 20 to 50 kilowatt hours, right? So you need proportionately that much more cooling capacity to cool GPU compute as compared to CPU compute. Now, if you get HVAC systems to do this level of cooling, you just blow cool air over. It's very inefficient. You really have to chill air rapidly, and you then end up spending a lot of electricity and a lot of power, to get the same amount of cooling. So architecturally, you need to move towards different types of cooling systems. Like as a first order effect, that is really different in AI infrastructure, right? So the specific choice of liquid cooling system can vary, and we go into a lot of detail in the report. But broadly speaking, you can think about closed loop liquid cooling systems, which are extremely efficient, and they bring cooling directly to the chip. So you have a liquid that's in contact with the chip, and you exchange heat with the chip, and then that liquid has to be recirculated. Or you have hybrid cooling systems where you basically blow air through water-soaked pads, and then that exchanges heat with the water, and it's a lot more efficient, right? So those are the two broad categories. Infrastructure-wise, you have closed-loop liquid cooling systems and hybrid cooling systems, right? So in addition to that, when you think about trade-offs when it comes to the infrastructure, if you are a data center operator that already has an established infrastructure, you're going to have to retool that infrastructure in order to accommodate these two different types of toolings. And so that introduces additional amounts of complexity as well, right? So this is not a topic that gets much airtime when it comes to mainstream discussions. And so people are singularly focused on power capacity, as we discussed, and nuclear versus natural gas, or GPU wars between AMD and NVIDIA, right? So these are extremely important, but there are cooling technology trade-offs are extremely important when it comes to AI infrastructure, and they don't get the airtime that they deserve.
So if I were to think of my former self in my pre-water career, completely focused on data center design, you're 100% right that all aspects of water and everything that you mentioned becomes sort of like the indirect, lower list on the priority, definitely not, top of the list. So if you're a data center architect today, what should be some of the things that you would think that they should be taking into account as they plan for expansion over the next 5 years, especially while being mindful of resources like water? And you've touched upon it briefly, but would love to kind of get a little bit more into detail for some of the audience here.
Yeah. So I think from an architecture perspective, it's all about trade-offs. But broadly speaking, based on the research that we have done, what we think is that hybrid water-based cooling techniques like evaporative cooling, adiabatic cooling, that will be the trade-off that data center operators will gravitate to, right? And there are two straightforward reasons for that. The first is that the cost of cooling for using these techniques, it's about 1000x cheaper than purely HVAC based systems. So they're obviously better than HVAC based systems. But if you compare them even to sort of liquid-based cooling solutions, like closed-loop liquid-based cooling solutions, the cost of retrofitting hybrid cooling onto an existing data center, it's trivial compared to completely retooling and redesigning and rebuilding the entire data center around closed-loop liquid cooling. The moment you start talking about hybrid cooling, you have to discuss water availability, because you need continuous uninterrupted supply of water to operate. You need water discharge permits. You need monitoring equipment that ensures that the water discharged is within permitted limits. You also need to tie up with a downstream utility to treat this discharged water, right? So then that sort of gets into trade-offs on the geographies in which you can operate, because you need a continuous supply of water. So that's an additional trade-off that you need to worry about. So, and finally, when you're utilizing water, this is, unfortunately, it ends up typically being a zero-sum situation where your water usage is subtracting from the local community usage, right? It doesn't always have to be, but it ends up being that way. And so that's caused a lot of heartburn for some data center operators in recent times, right? So that's another factor that you need to consider in your trade-off math, right? So those are some of the things that data center operators, I think, will need to worry about as they plan expansion.
Any advantages or disadvantages as you think about trade-offs and ideas that you can share specific to retrofitting an existing data center versus building a net new data center? I remember the days when we had a data center in California for one of the companies I was working for, and we decided to move our entire data center and build brand new data centers in Arizona and not be in California, which was a pretty heavy lift and intense operation. But in the net sequence of things, it landed up being quite economical and the right decision for the company. So any best practices that you would consider in the planning as it associates with water, but mainly as a lot of data centers are trying to keep up demand and think of expansion on their existing ones versus building new data centers?
Yeah. I think before we go into the details of that, it's useful to sort of disambiguate the types of data centers, right? So you have co-location-based data centers,
Right.
which are basically third-party data center operators that lease real estate space
Mhm.
and networking equipment and power, and you can just bring in your compute equipment and operate your data center, right? So co-location-based data centers are about 25% of the North American market. Then you have hyperscalers like Microsoft, Google, Amazon, the big players. And that's another 20 to 25% of the data center space. And surprisingly, at least surprisingly for me, when I was doing the research, the vast majority of data centers in North America are basically on-prem data centers. So close to 60% of the data centers are on-prem, right? And when you think about the distribution that way, the trade-offs for each one of these data centers is going to be different. So let's take co-location-based data centers as an example, right? So let's say that you are a co-location-based data center operator. You want to add AI to your existing compute infra. Now, it seems very logical from that perspective to sort of gravitate towards hybrid cooling rather than invest in liquid cooling, because the cost of creating something from scratch is not justified, especially if you've not fully realized profits from your existing capex on conventional compute.
Mhm.
Now, the trade-off is completely different for players with deep pockets that will own GPUs for a very long time, like the Googles and the Amazons and the Microsoft. So for them, that extra performance and efficiency when you use liquid cooling, closed loop liquid cooling, it's worth the cost, right? And so creating everything from scratch, it seems to be a no-brainer for that category of data center operator. But there's evidence that suggests, based on the work that we have done, that even these companies are adopting hybrid cooling systems and water-based cooling simply because it's so cheap. You don't have to spend a whole bunch of money upfront, right? I think regardless of what choice you end up making, from our perspective, the broader trend to keep in mind is that as AI data center growth explodes, the proportion of conventional cooling is set to go down, and the proportions of both liquid and hybrid cooling continue to increase, right? And that really has enormous implications for both data center operators and the utilities that work with these data center operators to treat their discharge. And of course, for the communities in which these data centers operate.
In your opinion, what are some of the things that utilities should be doing about this, as data centers in their local cities and local regions just ramp up drastically for the next decade with sort of like the demand that they're bringing to the table?
Yeah. That's a great question. So, we've spoken to and we've worked with a number of utility and wastewater operators in this space. And so there are a couple of learnings that stand out to us at KETOS. So the first thing is that, and that's really what led to us going down this rabbit hole of AI-focused data centers, is that no one is really anticipating exponential growth in wastewater discharge, right? And in some sense, that is understandable, because unless you're really involved in planning for AI capacity growth, it's very difficult to understand how explosive this growth is currently and how much more explosive it's expected to be.
Mhm.
So that's really the first order effect. When you have second order effects like wastewater discharge, it's even more difficult to anticipate. So I think the first thing that we can do to help utilities and wastewater operators is really to educate them about what's coming down the pike, right? And that's really what has prompted this report and this webinar, right? So that's really the first thing, education and really knowing more about this topic. The second really is our mission statement almost. You can't manage what you don't measure, right? So unless and until data center operators proactively adopt water quality monitoring to know what's in their water and how much they need to treat it before discharging it, it's going to be very difficult, right? So to just stay on that point a little more, let's take a hypothetical situation. You're a utility in Virginia, Virginia, Oregon, take your pick. These are areas where there's lots of data centers that operate. And let's say you've budgeted for 1 billion liters of produced water to flow in your to be treated. And that also includes, for instance, assumptions on what the average levels of nitrate are, what the average levels of phosphate are, and so on over long periods of time. Let's say you've budgeted for that. But now let's say that a lot of these data centers that are operating in your watershed, they switch their cooling to hybrid cooling or liquid cooling, and the amount and nature of the water discharge changes, right? And the contaminants that are being discharged changes, and you are working on an operating budget that accounts for X amounts of nitrate and phosphate, and that has completely changed. Then you're going to be in trouble, right? So your operating budget needs to sort of reflect the additional load of all of these contaminants that might be discharged, right? So your planning needs to reflect that as well. I think figuring out what's in your water and how data center operations might change that is sort of the first order thing that you can do. And it's, easy to do that because, that's what we are here at KETOS for, right? This is not limited to utilities working with data centers. The thing that, again, gets ignored in this discussion is power generation, right? For every kilowatt hour of power that is consumed at the end user, at the user's end, there's about 6 to 7 liters of, fresh water that is utilized. And an equivalent amount of wastewater is generated as well. So even utilities that are working with power generators, they need to manage for this as well, because if you are going to have exponential increases in power generation and you're not budgeting for that growth in your wastewater budget, then you're going to be in trouble. The operative question from our perspective is, are you ready for what's coming? Do you have the budget? Do you know what's in your water, right? And ensuring safe water quality is really the reason that KETOS's flagship product, the Shield, exists, right? So, we enable utilities and wastewater operators to know in extremely minute detail the quality of their water 24/7, right? So we have automated scheduled sampling of about 30 water quality parameters, all the way from simple parameters like pH to complicated parameters like mercury, copper, lead, and so on, right? And utility operators can get those results delivered instantaneously to their devices. And you can export that data via API calls. You can integrate SCADA into your KETOS account. So what we're doing is we're really providing real-time water quality intelligence as a service, and that utilities need to transition from a manual sampling-driven model where you don't really know what's happening in the interim to a hands-off sort of zero capex model that we offer, where we handle the hassles and you just get your water quality data, right? So we're here to help, and if the growth in AI pans out, you're going to need it. You're really going to need all the help that you can get.
What are some things we just cannot ignore with this AI revolution? And you've sort of touched on this through different responses, but if you can combine those with, sort of like what are some of the summary key takeaways, that would be fantastic as a gist for our talk today.
Yeah, absolutely. So if it's helpful, we'll give some key takeaway messages for our audience.
Yeah, that'd be great. Thank you.
So I think the first thing to take away is that all the discussions on AI are not hype, right? So there are parts of it that are real, and specifically AI capex is real. The growth in AI capex is real. It's explosive, especially when you consider that it's hundreds and billions of dollars that are being spent, and that's going to grow at minimum 10 to 15%, and realistically 20 to 35%. So just imagine that growth, right? So it's growing explosively, and all the hyperscalers have made their position very, very clear on this. They would rather overinvest in AI infrastructure rather than underinvest, right? So that should give you an idea that all of this growth is real, right? So downstream of that, you then need to worry about what this AI infrastructure expansion entails, right? So it needs compute, it needs power, but our position is that it also will need an enormous amount of water, and as a consequence, it will also discharge an enormous amount of wastewater. Right. So the second takeaway is that we anticipate hybrid and liquid cooling to dominate in coming years. And consequently, the amount of wastewater that will be generated is going to be enormous. Our calculations tell us that if these growth numbers are at all realistic, the amount of wastewater that will be generated, just from the expansion of AI data centers globally over the next 10 years will be equal to almost half the total amount of wastewater that's being generated in North America right now, right? So that is an enormous amount of wastewater, that is going to come on in the next 8 to 10 years, and that needs to figure into the calculations of planners, right? And the third takeaway follows from the previous two, which is that utilities and wastewater treatment plants and municipalities, they're not taking these projections into account. So you need to know what's in your water. You need to plan for the future. And we at KETOS are here to help you in your journey of planning this, and basically answering the question, what's in your water? We're here to help, right? So I think those are the few takeaway messages that the audience can take away.